Yesterday we learned how to factor trinomials that are in this format. So ax squared plus bx plus c. And in all of these examples, a, the number in front of the x squared or k squared, whatever it is 1. And when it's 1, it's pretty easy because you can just do the diamond method, which is set up here. The top of your diamond is always a times c. So in this case, it's always 1 times whatever number is in the c position. And then on the bottom is the number in the b position. And you're looking for two numbers that multiply to the top number, but add to the bottom number. So I get a positive 3, a positive 4, and I write it as a product of two binomials. So whatever variable they use x. Put your parentheses, put the variable, put your two factors that you found, and the signs will depend on whether they're positive or negative in your diamond. So that's what we did yesterday. Tons of different examples where some were negative, right? Lots of good stuff there. So definitely watch the video if you were working on something else yesterday or if you're on it. But we did not get to this part, which is examples with the GCF. Now, the resources that I've been pulling from organize everything and tell you when to look for a GCF. They kind of failed to mention that you should really always be looking for a GCF first. Like on the test, it's not going to tell you necessarily check for a GCF. You just have to know that you need to do that. Miss Medina. Okay. Nice. Ethan, thanks for going home. All right. So then, you really should always be looking for a GCF first before any factoring situation. You notice in these examples, none of them have a leading coefficient of 1. In this whole set of examples, they all have a GCF though. So for number 23, between 4, 12, and 8, what would the GCF be? That's the greatest number that can be factored into all three numbers. So always check the smaller number. If it divides evenly into the others, that's your GCF. If not, maybe make a factor tree and explore other options. All right, can I factor a k out from each term? No, because the 8 does not have a k. So right now the 4 is the only thing in my GCF. GCF always goes outside parentheses. Inside is what you get from dividing by your GCF. So divide each one by your GCF. I get k squared plus 3k plus 2. So everyone see how we just divided by the GCF. Good there? All right. Now, before I box this up and say that's my answer, it can't be factored anymore, you do have to check the parentheses. If it can be factored using any one of the methods that we learned so far, so far we've learned difference of squares and the diamond method, then you have to factor. So how many terms are in my parentheses? 3, it's a trinomial. Is it in the format ax squared plus bx plus c? So, and is my leading coefficient 1? So then I can use the diamond method on this problem. So on top of my diamond would be what number? On the bottom would be what number? And then I need two numbers that multiply to 2 but add to 3. 2 and 1. And they're both positive in this example. So GCF stays outside the parentheses. Inside, we set it up like how we did yesterday, k plus 2 and k plus 1. How could I check my answer to see if I did it right? FOIL and or distribute. You have to actually do both. It doesn't really matter what you do first, but after spoiling and distributing, you do get the original problem. Some questions on 23. All right, let's do 26 together, and then I'll give you a couple to try. So 26. Look for a GCF first. So between 330 and 63, what would the GCF be? 3. So 3 does divide evenly into the other ones. Can I factor out an A? Yes, what's the most I can factor out? Just 1. So they all need to have an A to be able to factor it out. Always take out the smaller exponent out of the 3. So 3A is my GCF. I'll do the scratch work over here. So now we need to put in parentheses what we get from dividing by the GCF. So 3A cubed divided by 3A. What does that give me? A squared. I have 30A squared divided by the GCF, 3A. We get 10A. And then we have 63A divided by 3A. The A's cancel. What's 63 divided by 3? 21. All right. Now, sometimes you're done there. Sometimes the parentheses can't be factored anymore. But in this case, it can be. So it's a trinomial. It's in this format. So we can set up a diamond, and I'll just have to kind of squeeze it in here. What would be on top of the diamond? What would be on the bottom? And what are 2 numbers that multiply to 21 to add to 10? Good. So then 3A, my GCF, will just be outside parentheses. Then you set it up just like yesterday. A plus 7 and A plus 3. And they're both positive, so that's why they're both plus. Questions about 26? All right, so then the ones that you guys will try will be 27 and 28. We'll go over them. I'll give you 2 minutes. We'll go over them in 2 minutes. If you finish early, then do start your practice. And make sure you're doing the 7-3 day 1 practice. That's the one from yesterday. If you try the day 2 practice, we haven't gone over that yet, so don't start the day 2 practice yet. If not, then just listen to the explanation. All right. So really, you should always be checking for a GCF first. And in these 2 examples, there is one. In 27, the GCF is 2 and 2 only. I can't factor out a B because there's not a B in all the terms. All right, so 2 is the greatest common factor. In the parentheses is what we get from dividing by the GCF. So questions about that part? All right, now I didn't box that up and say that that's my answer because the parentheses can be factored more. It's a trinomial. It has a leading coefficient of 1 so that you can use your diamond method on. So set up your diamond. It should look something like this. What numbers multiply to 6 but add to 5? Good. And they're both positive in this example. So that's why it's plus 3 and plus 2. Questions on 27? Yes. Where did the 6 come from? So from this part right here, the rule for setting up your diamond. So this, like I can factor with the diamond method. The rule for setting up the diamond is that the top is A times C, which in this case, all the A's are 1. So C, the number in the C position is 6. 1 times 6 is 6. On the bottom is the number in the P position. So you identify the GCF, which is 2, and then you divide it from each of the terms. So 12 divided by 2 is 6. All right, good question. Any other questions? All right, so then 28, same thing, except now our GCF has a variable because there's a y that we can factor out from each term. I can't factor out an x because there's not an x in each term. So 5y is my GCF on this one. Divide each term by 5y. Here's what we get after doing that. Any questions about that? All right, and then this right here, you can factor with your diamond method, what's in the parentheses. So I have -28 on top, -3 on the bottom. What two numbers multiply to -28 but add to -3? And one of them has to be negative because if we multiply to get a negative, which one does it have to be? Good. If you put it on the 4, that would be incorrect. Because they have to add and give you a -3 when you add them. All right, and then set it up. Since it's a -7, that's why it's minus. And then it's a +4, that's why it's plus. All right, someone earlier asked, can I write it 4 plus x? Sure, that's not any different. But like if you wrote 7 minus x, like that would be incorrect. So I'll kind of like caution you away from changing the order. Just write the variables first. I think that'll just keep it all the same so that you don't make a mistake. All right, questions on these two? All right, so I'm gonna play the morning roar. I'm also gonna put you guys on a timer because I don't want us to spend too much time working on the day 1 practice because we do have something else we need to go over today too. So work on your day 1 practice, not the day 2 practice. You don't know how to do that one yet. I'll give you about 15 minutes. So by 10, hopefully you should be done with it. You can check your answers as you go on the back wall. All right, so this is number 20 from the practice. So look for a GCF first. There is not going to be one with the numbers because my numbers are 1, 2, and 48. So 1 won't be the GCF. We don't factor out a 1. Can I factor out any x's? How many? Just 1. So check to see if each term has an x. If you do, or if they all do, always take the one with the smaller exponent. So x to the first is the one we factor out. So that GCF always goes outside parentheses. Inside is what we get from dividing each term by the GCF. So for that, you need the quotient rule. So here's like what you're doing essentially. What's the coefficient if it's not written? 1. And the quotient rule says to subtract the exponents. So 3 minus 1 is 2. We get x squared. Then we have 2x squared divided by x. Basically, it's 2 over 1. There's no other number on the bottom. What's x squared divided by x? Just x, good. And then -48x divided by x. The x's cancel. It's just the -48. All right, so far all we did was identify the GCF as x and divide all the terms by x, put that in parentheses. So good so far? All right, now before you like box it up and say that you're finished, do check if you can apply one of the other factoring methods on the parentheses. And you definitely can in this one, because we have a trinomial with a leading coefficient of 1. So for that, you can use our diamond method. What number will go on the top? What number on the bottom? And 48 does have quite a few options for numbers that multiply to 48. So if you need to make a list, then make a list. But you need to find a combination that will multiply to -48 but add to a +2. So what did you guys find? So a positive 8 and a negative 6. All right, just looking at my list of possible factors, these look like I could somehow make them work to add to a positive 2. All right, since this is negative, you know one of them has to be negative. Since it adds to a positive 2, you know it has to be on the smaller number. All right, so GCF stays outside. Write your parentheses as a product of 2 binomials. Make sure it's x minus 6 since it's negative here. That makes sense? Any other questions from the practice or just in general? All right, so then have the note sheet in front of you that you picked up from the back table. While you're doing that, just a couple general announcements. We are now on to the day 2 of the lesson, which is factoring trinomials in that format when A is not 1, so not equal to 1. We can still use the diamond method, but we also have to incorporate what's called the slide and divide method. So you can't just jump into the diamond method right away if the leading coefficient is not 1. You have an extra step in there which you'll learn, but either way your answer needs to be the product of 2 binomials. I'm recording now and I'll link it in the slides if you need to watch it because you were taking a benchmark or because you were absent, it'll be in there. And a couple other short helpful videos, I'll probably show you one of them someday, but we're kind of short on time, so I'll show you it a different day. The practice attached to this lesson is your day 2 practice. So we're going over how to do those problems now. We won't have time to work on the practice today, but if you want to get a head start after the lesson, go ahead. So the exit ticket will be pushed to tomorrow. We'll definitely take it tomorrow. And it'll be over the 2 days of material. So when A is 1 and when A is not 1. Any questions about that? All right, so then we're gonna skip the warm up on your note page because I feel like we're warmed up by now. We just finished the practice and stuff. So let's look down here. And I'll come back to these steps. They call it like the slip and slide method. Other people call it slide, divide, then slide. I'm just gonna kind of keep it simple and just have it be the diamond method, which we already learned, just with a couple added steps. So in this margin over here, write down what I write down. So we have trinomials in this form when A is not 1. All right, when A is not 1, here's what you do. You still set up your diamond. The top will still be A times C, and the bottom will still be the B. And you're still trying to find things that multiply to the top and add to the bottom. It's just now we're actually going to have something other than 1 for the A. So that first step will be the same. Once you get your 2 factors, you're going to need to divide the factors by A. So whatever was your leading coefficient, you'll have to divide it by A. Third, you'll need to reduce the fractions. And slide any remaining denominators. All right, so 2 added steps. After the diamond method, you'll divide the factors by A, and then you'll have to reduce the fractions, and then slide any remaining denominators And you'll see what that means in a second. All right. You're welcome if you find other methods that you like better. You're welcome to use them, but I think this one will be the simplest. So example 1. We see the leading coefficient is not 1. We still make a diamond, but we just have to remember to add these extra steps after that. So the top number will be what A times C is. So 2 times 3, those are the numbers in those positions. What's 2 times 3? And then the number in the B position will go on the bottom, which is 5. So if you didn't catch that, A times C on top, B on the bottom. And then I need 2 numbers that multiply to 6, but add to 5. Good. And then set it up like we did in the last lesson. So far I have x plus 3 and x plus 2. But that's not my answer because if I FOIL that out, I don't get 2x squared as my first term. So that's why you have to add these other steps. I need to divide the factors by A. So what number is in the A position? So divide them by 2. Usually one of them works out nicely. So you divide them by A. Reduce the fractions. So like this can't really be reduced further, but 2 over 2, what does that simplify to? 1. So this parenthesis will now be x plus 1. When we reduce the fraction. This one over here, it's already reduced, but it doesn't work out nicely. So that's where the slide comes in. You're going to slide the denominator in front of that x, and you write it as 2x plus 3 in parentheses. So it's diamond, then divide, reduce, slide, I guess are those steps. And now when I FOIL it, I do get the original problem. So this is my answer, and I'll prove it to you. What's 2x times x? And 2x times 1? 2x. Inner terms, 3 times x. And last terms, 3 times 1. And when I combine like terms, which I'll just do that in my head, don't I get the original thing? Yes, so that's how we know we did it right. So questions about example 1? Yes. So it's always A times C. So the 2 is in the A position, 3 is in the C position. So it's A, B, C. So even when we did it where the leading coefficient was 1, it still was A times C. It's just A was 1. So it kind of just looked like C only. But it's always A times C. Any other questions? All right, let's do example 3 together, and then I'll have you try some on your own. So example 3, same thing. Set up your diamond. It's always A times C on the top. So what number will go on the top of the diamond? -24 is correct. So A times C. If you need to draw something, not know to remind you, go ahead. I see people draw that a lot. 6 times -4. On the bottom is the number in the B position, which is good. And now what are 2 numbers that multiply to -24 but add to -5? Good. So 24 is one of those tricky ones. It has a lot of options. I started writing down my options. And then you just kind of keep going until you find a combination that could somehow create a -5. All right, and for it to do that, the negative has to be on the 8. So far, this is what we have. Y minus 8 and y plus 3. Any questions about that? All right, but we're not finished because since we had to multiply 6 and -4, now I have to divide these by the A, by the 6. So divide the factors by A. Next step, we need to reduce the fractions. None of them really work out nicely, but we can reduce the fraction. So like what does 8/6 simplify to? Two goes into both of them, so it would be 4/3. That's what we have so far. We'll change it in a second. And then 3/6 simplifies to 1/2 is correct. All right. So sometimes I'll do my scratch work like over here, right? But you're simplifying the fractions. And then I clean it up down here. Now we're not entirely finished because we don't ever leave it like this. We always do that last step, which is to slide any denominators in front of the variable in that parentheses and then rewrite it. So our actual final answer is 3y - 4 and 2y + 1. So reduce the fractions as much as you can, and then if they don't work out nicely, slide the denominator in front of the variable. And then if you FOIL, even if just in your head, 3y times 2y is 6y squared. So any questions on example 3? All right, then try example 2 and 4. So it says when A cannot be factored out by a GCF, so you really should always be checking for a GCF first. You can still possibly factor the trinomial. So here's like, they call it slip and slide. It's just like the same thing we're doing. So what they said is slip A. So slip A to the end of the trinomial and multiply by C, which is what we did. And then it says factor this new basic trinomial. You can use our diamond method. Just remember it's A times C on the top, B on the bottom. And you're still finding two numbers that multiply to the top, but add to the bottom. All right. Then it says divide both your factors by the value you slipped over. I'm just going to kind of simplify that. Divide both of your factors by A. All right, whatever your leading coefficient is, divided by that. Then it says, just like we said, reduce the fraction, slide any denominators up next to the variable. So here, same thing, it's what you should have done. I'll go step by step with example 2. I'll just project example 4. But basically, set up your diamond. The top is A times C. So what number goes here? What number goes on the bottom? And what two numbers multiply to 30 but add to -17? And they both need to be negative. All right, so don't forget that part. If it adds to a negative, then they both need to be negative. If it also multiplies to the positive. So far I have m - 15 and m - 2, but we're not finished because when it's not a leading coefficient of 1, you have some extra steps. So we factored it. Now we need to divide the factors by A, which is 5. In this one, it works out nicely. What's -15 divided by 5? So m - 3. This one doesn't work out nicely. Can we reduce the fraction anymore? No. So that's when you slide that denominator in front of the m, and it gets rewritten as 5m - 2. All right, and then you can always distribute to check. I'll project the other one, so give me a second. Oh, hold on. I guess I didn't have it up. Make sure you have example 4 filled in with the correct answer. Here it is. As we'll just do a few more examples tomorrow, some with GCF, and then you'll have time to work on your practice and do all that. All right, so they call it slide and divide. So slide that 12 over, multiply it by the -5, factor it out. The online notes don't really use the diamond method, but here it is just in case. 12 times -5 is -60. 11 goes on the bottom. 15 times -4 makes the whole diamond. That's why they have +15 and -4. Divide by your A, which is 12. So divide by 12. Reduce both of the fractions. None of them work out nicely, but you still need to reduce them. And that's how they are rewritten. Questions? All right. So don't lose your practice. If you want to start it, I welcome you to. But don't lose your notes or your practice or finish it tomorrow.